Now that we've talked about expressions, both numerical expressions and algebraic expressions, and evaluating them, we're going to talk about some of the things that you can and cannot do with expressions and with numbers, and those things or those rules are called properties. And we're going to talk about some very important properties of numbers today. And a property is a statement that is true for any numbers. And some properties we're going to be talking about are the commutative property, the associative property, and a few other properties. Now, the commutative property tells you that you can add or multiply numbers in any order, and it's not going to change the sum or the product. And the associative property is the property that says the way in which the numbers are grouped when added or multiplied does not change the sum or the product. So commutative property has to do with moving things around, and associative property has to do with grouping symbols, how we group numbers together. And counterexample is an example that shows that a statement is not true. So that's one way to show that if a property is true for certain numbers. If you can show a counterexample or prove that it's false, then we know that those operations don't have that property. And then again, simplify. To simplify an expression means to perform all the possible operations in an algebraic expression. And then we're going to use a little bit of deductive reasoning today, and that's using facts, properties, or rules to reach valid conclusions. So first, the commutative property, again, says the order in which the numbers are added or multiplied does not change the sum or the product. So we can rearrange numbers when adding or multiplying, and it's not going to affect the outcome. So this is something that's true for any number that you can come up with. If you're adding and multiplying, it doesn't matter the order in which you do it. You're going to get the same answer regardless. So a couple of examples here at the bottom of the screen when you probably use the commutative property subconsciously without realizing it. So if I were to ask you to add these three numbers mentally, 43 plus 18 plus 17, some of you probably wouldn't go just strictly left to right. You might notice that it might be a little easier to add these numbers in a different order. Well, you're using the commutative property when you do that. So for example, if I use the commutative property to rearrange the 17 and the 18, I can actually add these numbers in this order, and it's not going to change the sum, which makes it a little bit easier to do. 43 plus 17 is 60, and 60 plus 18 is 78. So I can evaluate that numerical expression very easily using the commutative property to my advantage. The next one, lots of different ways that you could do this. Actually, we probably could use the associative property here too. If you were asked to do this mentally, you might do the 8 times 5 first, or some of you might rearrange the numbers and do the 6 times 5 first, or something times 5 first. So right now, the order of operations would tell us to go left to right, but thanks to the commutative property, we can actually multiply these in any order we want. So I'm going to use the commutative property to rearrange the 8 and the 5. I'm going to do the 6 times 5 first, which is 30. And then 30 times 8 is 240. It makes that a little bit easier to do. So properties of numbers help us to rearrange expressions to make them a little bit easier to do, or allows us to simplify an expression when the order of operations normally wouldn't allow us to. So that's the commutative property. You can rearrange numbers and expressions when you're adding and multiplying. The associative property, people understand this one a little bit less than the commutative property. Now, associative property, the numbers do not move. The numbers do not change their location in the expression. They stay in the same order, but we simply just change how they're grouped. Okay, we're going to group them in a different way. So we're not going to move the numbers. We're just going to associate them differently. And now to associate means to kind of group together or to be in a group. If you're associated with something, that means you're in that group. So this has to do with moving of grouping symbols. So moving of parentheses or moving of brackets. So a couple examples at the bottom again. As is this expression 17 plus 13 plus 19, I would have to do the 13 plus 19 first if I was following the order of operations because they're in the grouping symbols. But I notice if I reassociate these numbers, if I associate the 17 and the 13 together, so I'm just simply moving the parentheses, notice the numbers are all still in the same order, 17, 13, 19, but now I've just associated them differently, I've grouped them differently, and the associative property says that you can do this when you're adding or multiplying. So now I can add the 17 and 13 together, which is 30. It's a little easier sum to find, and then 30 plus 19 is 49. So it makes that numerical expression a little bit easier to evaluate just using the associative property. So again, the associative property on the next one, this is all multiplication, so I can actually regroup these numbers. I'm not going to rearrange the numbers, I'm just going to regroup them. I'm going to group the 15 and the 4 together, because 15 times 4 is a little bit easier to do mentally than 4 times 9 and then multiply that product times 15, because I don't really want to do 36 times 15 mentally. So the 15 times 4 is a little bit easier to do, which is 60, and then to take 60 times 9 you get 540. Again, easier to do thanks to the associative property. So those are the two really major properties that you're going to run into throughout your math career, is the commutative property and the associative property. You have to know those properties, because when we get into algebraic expressions, you have to be able to know how you can and cannot rearrange an expression. Here's a couple of other number properties that might seem like no duh, but we have to know them, and they are properties that are always true. One of them is the additive identity property. So when you think of identity, you think of what you are. So when you add something to some number, it doesn't change what you are. Its identity stays the same. So it says that when 0 is added to any number, the sum is that number. So if you add 0 to something, surprise, it doesn't change. Okay, that's obvious, but it is a property of all numbers. That's true for any number. You can add 0 to anything and it won't change it. So algebraically, that looks like this right here. For any number, a plus 0 is going to be just a. Okay, so the multiplicative identity property, which is one of my favorite properties to say, multiplicative identity property, when any number is multiplied by 1, the product is that number. So multiplying anything times 1 does not change its identity. So we have an additive identity property and a multiplicative identity property. And in both of these cases, the number never changes. So I can either add 0 or multiply by 1. That tells me that the number is not going to change, or the value is not going to change. So a times 1 or 1 times a is just a, no matter what a is. And then lastly, the multiplicative property of 0, that tells us that whenever you multiply something times 0, you get 0. So if a is any number, a times 0 will always be 0. So a few more properties there to round it out. Now, do these properties apply to subtraction or division? Because we've been talking about addition and multiplication this whole time. Well, let's test these two major properties here, the commutative property and the associative property. So here I have two numerical expressions with subtraction using the commutative property. So I rearrange the order of the numbers. So the question is, are these equal? Well, 18 minus 6 is 12, and 6 minus 18 actually is not 12. It's negative 12. So these two values are not equal. So that is a counterexample. That shows me that the commutative property does not work for subtraction. All I need is one example that shows it's false, because remember, a property is something that is true for all numbers, no matter what. So if one doesn't work, it doesn't work. Okay. And now I know you could probably show an example where it is true, like 10 minus 10. Is 0, and then if you rearrange it, it's 10 minus 10, which is 0, but that's a special case. That's only one case where it's true, and all we need is one case where it's false to show that it does not have the property, because it has to be true for all numbers. What about division? I have 10 divided by 5. Is that equal to 5 divided by 10? Well, 10 divided by 5 is 2, and 5 divided by 10 is not 2. It's actually 1/2. So these two quantities are not equal. There's a counterexample that shows that division does not have the commutative property. So let's look at the associative property for subtraction and the associative property for division. So here again, the numbers did not rearrange, they were just changed how they were grouped. So on the left-hand side of our equal sign, we've got the 20 minus 10 grouped together, and on the right-hand side, we have 10 minus 3 grouped together. So we have to do those first. So 20 minus 10 is 10, and 10 minus 3 is 7. And on the right-hand side, we have to do the 10 minus 3 first. So I have 20 minus 7, which is 13. And these two values do not end up being the same. So the associative property, not going to happen for subtraction. Does not work. And then lastly, division. I'm going to do the 24 divided by 6 first. 24 divided by 6 is 4. 4 divided by 2 is 2. And on the right-hand side, I have to do 6 divided by 2 first. And I get 24 divided by 3. 24 divided by 3 is 8. 2 is not equal to 8. So again, a counterexample that shows that division does not have the associative property. So these two properties only apply with addition and multiplication. So let's play a little name that property. So I have some expression or equations here actually, and I want you to try to identify what property is shown in each statement. So if you want to pause the video and see if you can figure these out before I explain them, please do that now. Otherwise, I'm going to jump in and show you what properties are shown here. So in the first one, we have d plus 0 equals d. So I'm adding 0 to something and it's not changing its value at all. So this is the additive identity property. I'm just going to put additive identity to save time. Next one, 8 times 1 is 8. So here I multiplied a number times 1 and it did not change its value. This is the multiplicative identity property, my favorite property to say. Multiplicative identity property. Next one, 4 plus 9 plus 10 equals 4 plus 9 plus 10. The only thing that is different on each side of this equation is simply how the numbers are grouped. They are not rearranged at all. They are in the same order. We just changed what numbers were grouped together. So this is the associative property. And then the last one, 5 times 7 times 2 is equal to 7 times 2 times 5. Here the numbers did rearrange. We're talking about multiplication here, and they rearranged. These products are going to be the same thanks to our good buddy, the commutative property. So identifying properties when you see them. And then lastly, we're going to talk about how to use these properties to simplify algebraic expressions. Now, to simplify an expression, we have to perform all the possible operations. So sometimes when there's a variable involved and we don't know the value of that variable, it makes operations not possible. But if we use some of the properties we learned about, we can perform operations. So right now, this first expression right here, 3 plus e plus 7. I have to do 3 plus e first because it's in parentheses and the order of operations says I have to do what's in the grouping symbols first. But since I do not know what e is, I cannot evaluate that. So normally I would be stuck. But since we're talking about addition here, I can use some properties. So what I did is I used the commutative property to rearrange the 3 and the e inside the parentheses in this step right here. So all I did was rearrange the e and the 3. The commutative property says I can do that when I'm adding. And then that allows me to move the parentheses and use the associative property to group the 3 and the 7 together. Now I can perform that operation because I can do 3 plus 7, which is 10. And I cannot do e plus 10 if I don't know what e is, so that is the end of the road for us. And we say that the expression is simplified once we reach the end of the road, and there are no more operations we can perform. Next example, very similar, but with multiplication. I have 8 times x plus 5. Well, the x plus 5 is in parentheses again. I cannot perform that operation because I don't know what x is. So I have to do a little bit of mathemagic here. I have to use my properties to rearrange these items so that I can perform the operations. So I use the commutative property again to rearrange the x and the 5 in that step right there. And then I use the associative property to move the grouping symbols or the parentheses to put the 8 and the 5 together. Now I can multiply 8 times 5, which is 40, and so I have 40 times x or 40x, and that is in simplest form there because I cannot take 40 times x. There are no more operations I can do because I don't know what x is. And then in these last couple here, I use the additive identity property because 0 plus m is just going to be m. Anything plus 0 is just itself. So then I ended up with 9 plus m after I used the additive identity property, and that is that. Since I don't know what m is, I can't take 9 plus m, so then I am simplified. And then the last one, I have 4 times a times 0. Well, a times 0 is going to be 0 no matter what a is, thanks to the multiplicative property of 0. And that's what I did here in this step. And then I applied the multiplicative property of 0 once again. 4 times 0 is going to be 0, and we are simplified. So using our properties of numbers to help us evaluate numerical expressions and simplify algebraic expressions.